Hi all, good afternoon to everyone. In the last session, we have focused on functions, then a global variable, local variable. Have you all gone through the last session? Have any doubts in that? Have any doubts in the previous session?
No, sir.
Okay, Sai Bhargav, Vignesh, Manasa, others.
Sir.
Okay. In this session, we focus on important topic called storage classes. Storage classes. So here we are going to see about how to declare the variables. How to declare the variables using
Sir, are you sharing the screen?
1 minute. Storage classes. So here we are going to see how to declare the variables using the different keywords. Say R2 register static install storage class, right? This tells in what way the variables are declared and how the scope and their lifetime will be. Scope and lifetime will be. We see in detail, right, what is the scope. Scope, this is nothing but the visibility. Lifetime, this is defined using another term called longevity. Scope means where a variable can be accessible. What is the accessible region? We need to find the region in which the variable can be accessed. Lifetime means how long a variable retains its value. That is lifetime. So, to have the different scope as well as lifetime, we need a concept called storage class. Storage class that defines the scope and lifetime of variables with respect to different aspects. For example, we can have the scope with respect to a function or with respect to the program or anywhere within the same program or anywhere within some other files. So this way, how a variable is going to be stored and accessed. That is the logic of a storage class. Storing of a variable and accessing the variable, right? That is the concept of storage classes. So before going to see, right, the first one, auto storage class. First, let us look how a variable is declared and how it can have a local scope. For example, first one, let us recall what is a local scope. Local scope is a scope which is defined within the opening and closing curly braces. Local scope defined within the opening and closing curly braces. For example, have a look into the scope. hash into stdio.h into name return 0, have a function called suppose f of n, assuming n is for one integer variable, int n is equal to 10. Here we do like to print a value, printf slash n is equal to percentage degree, comma n. Inside the function, the f of have the same variable int n. First let us print the value, printf slash n is equal to percentage degree, comma n. Let us update the value of n. Suppose n is equal to n star 10. Have the function prototype f in save the file f2. File name is file pp 62. Save pp 62. Compiling the code F9. No compile time errors. Control F9. As we expected, first write the function f of n is called. It prints the value of n, right? N is equal to percentage d n. What is n here? N is the actual parameter. Actual parameter is passed as a formal parameter. I write a detailed explanation. Please take it. This n is the actual parameter. This n is the formal parameter. You know that during the function call, the actual parameter is assigned to the formal parameter. Hence, the actual parameter n is assigned to the formal parameter. Here, what happens? We need to consider a local scope because inside the main function, one variable n is declared, right, and defined. So, with respect to a main function, please check this. With respect to a main function, here one variable n is defined, which is of integer type. That means the variable n is created when the control enters into the statement or main function. N is initialized to a value 10. Then we have called the f of n because f of n, this is the function call. Inside this function, say f of int n, actual parameter is n. This is assigned to the formal parameter. N is equal to 10. The value of actual parameter is in general assigned to the formal parameter. This n is actual parameter. You should be very careful. In all programming languages, right, this is common. This is the formal argument or formal parameter. Actual parameter value is assigned to the formal parameter. In the last class, we have explored what is a local variable. A variable defined within the function is said to be a local variable. So within the main function, opening and closing curly braces, we have defined the variable n. So this n is local with respect to this main function. That means this n can have the scope only with respect to this opening and closing curly braces. Inside this function definition, all formal parameters are local variables. So here, with respect to this function n, we need to create another variable in the system memory, and the value of n is received from the actual parameter. So this n, which is of type integer, stores a value type, that is f of n. So n is the actual parameter, here n is the formal parameter. This n is not the same as that of this formal parameter. Even though, right, the value of n is received here, it seems that if you make any change in the function definition with respect to a variable n, this will not be reflected in the n which is available in the main function. Of course, this is a logic called call by value, right? We focus later, right? Again, the same logic, right? Call by value. So here the value of n is printed as 10. Subsequently, if you write n is equal to n into 10, so here n is equal to n into 10 means the n which is available in the function definition, this gets updated to 100 because n is equal to n into 100. Current n is 10. 10 into 10, 100. This is being updated in the local n, which is defined with respect to this opening and closing curly braces. So this is the logic of a local scope. Now, once when the function f has been called, the next executable statement is following this function call. So here, if you print the value of n, this n is actually taken from this opening and this closing curly brace. So this n, right, prints again the value 10. Don't confuse this n, right, in the function definition f of ntn, right, even though the value of n is updated to 100, this 100, right, is the value of the local variable with respect to this opening and closing curly brace. Opening and closing curly brace, local scope. So when the control comes out of that local scope, again when it re-enters into the main function, printing the value of n remains 100. This n is not the same as that of this n. Likewise, this n or this n, this is not the same as that of this n. Even though the value is same, right, to assign the initialization to the formal parameter, different memory allocation is done, right, with respect to the storage. That's what this is a local scope. Int-n, right? This is a local scope with respect to a main function. And this n, this is a local scope with respect to the user-defined function. So, with respect to the scope, right, locally, this n is not accessible here. And this n is not accessible here. But you can have the nested scope, opening and closing curly braces. Just to have a look into this place, carefully note it. Just I put one opening and closing curly brace. So this opening and closing curly brace, this forms, right? This opening and closing curly brace, this forms a local scope again. Local scope again. So this is to be the inner scope. Inner scope. Here, I do like to print the value of n. Print dash n. Inner scope n is equal to percentage dd, comma n. Just having this executable statement. Inner scope n is equal to percentage d n. Now let us check the result. See what happens. This n, right, is actually defined with respect to the outer scope. Outer scope controls the inner scope. So within this opening and closing curly brace, please understand we didn't define a variable n. N is not defined within this opening and closing curly brace. However, the n is defined in the outer scope of this highlighted block. This is to be a scope, local scope or block or code block. This n is defined here. N is 10. That n is accessible here. That is the inner scope. So you can list write any number of times, even within this inner scope. I can use another inner scope. For example, here I do like to print the value of n again. Print of /n inner scope 1 n is equal to percentage d comma n. Now what happens? One outer scope. Within that we have first the inner scope. For example, our inner scope this is 1. Let it be inner scope 2. Outer scope right can access or will be accessible right in any of the inner scopes. So here in both of the inner scopes 1 and 2 the variable n is accessible, but the variable n is not even declared in the inner scope 1 and inner scope 2. The logical concept is since this is the outer scope variables will be accessible in all of the corresponding inner scopes. But the reverse, for example, here I define one variable, say character ch is equal to x. Within this, I define another variable, character or float f is equal to 1.2. So having these two variables, char x is ch is equal to x, float f is equal to 1.2, this closing curly brace and this opening closing curly brace. Here if we try print percentage c percentage f comma ch comma f, what happens? This results in the compiled line error because undefined symbol ch in function the variable ch is not defined with respect to a main function. Likewise, if you try to access a variable f here, f is defined with respect to this scope percentage c comma ch. This results in error. Likewise, print percentage f comma variable f. Let me comment on this line. F. What happens? F. I will define the variable f outside opening this one closing curly brace print percentage f right. I will type to the code correctly f9 control f9 Printer percentage F, this is not working. Printer percentage F, F equal to F9. Even right now, compile time errors. Control F9. Not see the output. For example, 1.2 F9. Control F9. I have another variable, say detected right here. Fg is equal to percentage F F9. One error here. What is the error? Undefined symbol Fg in function. So here, what is Fg? Fg is a variable which is declared right with respect to the local scope. This cannot be accessible in the scope which is defined. It's outer scope. So this results in error. Here also the variable, this results in error. Printer statement results in error. So what is the local scope? Local scope is a scope which is defined within the opening and closing curly braces. So just now we have illustrated local scope, nested scope, and nested, right? You can nest the scope any number of times. Outer scope variable can be accessible with the inner scope, but the reverse inner scope variable will not be accessible in the outer scope. So here the scope, right, is simply the visibility where a variable ch is visible, where the variable fg is visible, that can be accessed the variable here. That visibility, that is to be the scope of a variable. Understand? Have any doubts? And next we move on to the first storage class R2, right? The storage class R2, this is to be the automatic storage class. File automatic storage class. Automatic storage class, this is defined using the keyword R2. R2, right? This is the keyword. For example, let us define the variables using R2 keyword hash into stdio.h into main. Begin the opening and the closing curly braces. Have suppose int is equal to 1. R2, hope you can see the word is highlighted. So R2 is executed. R2 int y is equal to 2. Here you can print x is equal to percentage b, y is equal to percentage b, comma x, comma y. File, save, 63, 9, okay, control F9, x is 1, y is 2. What is the difference between int x is equal to 1 and R2 into y is equal to 2? The difference is the variable x is declared without the storage class and y is defined as the automatic storage class, but by default this is same as R2 int x is equal to 1. This is same as R2 int x is equal to 1. This means that the variables which are declared as R2 are said to be automatic variables, same as the default type are int x is equal to 1. So by default, what happens? Int x, this is same as auto int x. What is the purpose of automatic storage class? The automatic storage class defines the variables automatically, which means that their scope lies within the defined function. Their lifetime remains within the defined function. The meaning is scope lies within the defined function. Since by default int x is equal to 1 is same as auto int x is equal to 1. By default, all the variables are automatic variables unless declared using the keyboard R2. In that stage, the scope of automatic variables are defined only within the function, defined function. That means after the main or outside the scope of the main, you cannot access the variable x, as we discussed in the previous example. Likewise, auto into y is equal to 2, that is same as into y is equal to 2. That stage, since y is the automatic variable, its scope is defined only with respect to the opening and closing curly braces. Outside the scope of opening and closing curly braces, we cannot access the variable y. That is one part of the storage class called scope. Second one, the term is lifetime or longevity. How long a variable retains its value during the execution of the program. For example, here int x is equal to 1. The value of x is 1, right? Within this opening and closing curly braces. So wherever you want to print the value of x with respect to this program after this initialization, before auto int y is equal to 2, you can print a value of x. X is 1. After this printf, right, if you print the value of x, x is 1. You can print the value of x anywhere within this opening and closing curly braces. So the value of x, 1 is printed. But when the program execution finishes, automatically main terminates its execution. Then the variable x is lost, y is lost. The variables x and y will not retain its value. So that stage, we can have the automatic storage class. Or if you take another example by calling a function, here one function is defined, assuming that the variable y is initialized at value 50. Only within that function, the variable y can have a scope. Its lifetime is only defined within that block, code block. Code block means that is defined within the opening and closing curly braces. Once the control comes out of that opening and closing curly braces, or stated otherwise, when the function call has been completed, whatever the value of that variable defined inside that function, that cannot be accessible, right? So the value of that variable or its lifetime is defined only within the defined function. So how long a variable retains its value during the execution. Suppose a variable started its lifetime at t time. When the function rate finishes at a time rate, say t plus delta t, t plus delta t minus t, right? So simply The lifetime of the variable is a delta t, a short amount of time. So when the control comes out of that, the variable, right, will not retain its value and its scope is also closed. We cannot access that scope. That's what by default variables are comes under, right, all variables are, right, placing under the category called this one automatic storage class. So by default, right, whatever the variables you have declared earlier without R2, if you put a R2, there is no such significant difference because by default all the variables are assumed to be of automatic storage class. Understand the first one? Have any doubts in automatic storage class?
No, sir.
Okay, now let's see the second one, static storage class. Carefully understand this program. Static storage class. As the term, right, static, which implies that that's something fixed, right? Static. So static in the sense that the variable retains its value during the function calls. So just to consider this example, hash include stdio.h. Let's see how function call have been made and how a variable retains its value during the function calls. For example, int, I use the function g, void, sorry, int main, have a for int I is equal to 1, I less than or equal to 5, I f plus plus. I am calling a function simply g. Okay, have these two lines. Then define a function g. Not necessarily to have into g. Let it be void g. Void g. It is opening and closing curly braces. I define the variable some int some count. Count is equal to c. And I print a value of count. Print out slash n. Count in function called p is percentage d out. And I increment a value of count by count plus s. Let's save and check the code. File save VP64 F9. Okay, control F9. The code has been run. Okay. For int I is equal to 1, I less than or equal to 5, I plus plus. What is g? G is a function, sample function that we have defined, in which one variable count is defined, which is of integer type. Further, that int count is equal to 0 is same as that of R2 int count is equal to 0. Printing the value of a count right here in the first function call, count is 0. Then I is equal to 2, count is 0. I is equal to 3, count is 0. I is equal to 4, count is 0. I is equal to 5, count is 0. Further right, if you want to make a modification, here please pass a variable so that the variable I is passed here. Here I define a variable, suppose empty variable. Counting G or the value of or call, right? I could call percentage B equal count in G. First one is call, right? Call number. What is the call number? A is the call number. So F2, untrue, F9. Now we have a clear effect in the output. Call 1, count in G is 0. Call 2, count in G is 0. Likewise, call 3, calls 3, 4, 5, count in G is 0. Because the variable K and count are defined as local variables with respect to the function G. Once the variable A is printed here, suppose A is called count 1, count 2, 3, 4, 5. Initially A is 1 because I is 1. A is 1, right? Count is 0 printed. Count is incremented by 1. Count plus plus. What happens? Count becomes 1 in the first call itself. Once the control comes out of the function called G of I, of course the function is going to be called second time when I is equal to 2. The logical concept is, once the control comes out of the function call, as we seen in the previous examples, making n is equal to n into 10, that updated 100 in the local variable will not be reflected in the main function. That's what in the next stage, the first call of call, right, 1, count is 0 and count plus plus count is even incremented by 1. Next call, when I becomes 2, int count is equal to 0, that means the value of variable count is reset. Previously, right, even count is 1 in the first call. That count is a local variable. Count has been updated to 1 in the first call, but since the count is the automatic variable, local variable, by default, automatic storage class is considered. Once the control comes out of this G of I function call, the variable count is lost. Variable count will not be active within the main function. This means that, or this does not mean, when you re-enter the G function, count is equal to 1 will not be taken. Please understand, this does not mean when you re-enter the function G, previous value of count, that means the last value of count 1 will not be taken. You came out of a function G, that's all. The variable count will not be accessible. Previous value of count or last updated count will not be accessible. That is the lifetime. Only within this opening and closing curly brace. Here you can have a value of count to 0, then count to plus plus, suppose count is 1, then following that closing curly brace is there, but after this you can have any number of print statements of count. Count is 1, 1, 1, 1, right? Count is 1, that's all. Subsequently you can have any number of counts. But that incremented count will not be active once the control is coming out of a function G. So in the main function, who is count? Count is local to G. main cannot access the variable count. Another thing, inside the function g, count is starting its lifetime in this declaration only at the closing of the function. Up to that closing of the function, the variable count will be live or alive, both are same. Count will be live or count is active only within the G's opening and closing curly brace. Once the control has come out of this closing curly brace, that's all. The variable count is lost. The value of a previous variable or the previous value of the variable count is not retained in the second call. That's what I have said. When call, right, I becomes 2, G of 2. G of 2, what happens? A receives 2. Sequential execution is taken place. Again, if you write int count is equal to 0, that's all. The previous call count is updated to 1, but the current call when I becomes 2, here A is 2. The variable count has been reset. That means count is reinitialized to 0 in the second call also. So in the second call, here value of A is 2. Count, right, what happens? Count is resetting to a value 0, right? Count is resetting to a value 0, right? So previous count 1 will not be taken place. That will not be accessible to. Previous value of variable count is not retained in the successive or subsequent calls because the variable is coming under a concept or a category called automatic storage class. So when the variables are declared as automatic storage class, its scope is defined only within the function opening closing curly brace. Its lifetime is also defined only within the function. Hope you understand. This is right static. So this is not a static. This is, of course, the automatic storage class with respect to a function. First, you need to understand this example. Then we move on to right focus on static storage class with little modification. The same example. Have any doubts in this example?
Sir?
Yes.
Sir, what happens if count plus plus is not given, sir?
If count plus plus is not given, no effect will be because here is just think of when I is 1 is passed, A receives 1. Count is 0, the value of A and count are printed. When count plus plus is given within this function call for I is equal to 1, final value of count is 1. Please understand. When I is equal to 1, final value of count is 1. After that, we have terminated the program execution, terminated the function execution, not a program execution. So updated count is anyway, right, or no way, right, reused. That is not used the subsequent statement. Even if you write count plus plus any number of times, accordingly the count will get incremental with respect to this opening and closing curly brace. In case count plus plus is not given for each I, count is initialized to 0 and the value of count is printed. That's all. No effect will be taken place. But please think the longevity concept. Longevity means lifetime. How long a variable retains its value. That's what I have said. Here, this is the opening curly brace. Here, if you declare a variable, this variable is active only within this opening and closing curly brace with respect to automatic storage class. Before the closing curly brace, wherever you need, you can access the value of the variable. That's what in the previous examples, right? And we have illustrated like this. Suppose f of into n, assuming that the formal parameter n receives the value 10. Here, if you print the value of n is 10, then within this opening closing curly brace, have another local scope. Here, if you print the value of n is 10, then here you can have another scope. Likewise, you can have the nested scope. Here, if I put or print a value of n is equal to 10 is printed. So, lifetime, how long a variable retains its value. Since this is automatic variable retains its value only within the defined function opening and closing curly brace. So wherever you want within this opening and closing curly brace, in any of the inner scopes, the value of the variable n is 10. So that's what I said. When you declare or when you initialize a variable, right, n is equal to 10 at a time t, assuming that the control, right, completed its execution before the closing curly brace. For example, this statement at a time, say t plus delta t millisecond. Then the difference between these two, t plus delta t minus t, this is simply the delta t. For delta t seconds or milliseconds, the variable L is retaining its value, or the value of n is accessible, or the lifetime of a variable n is defined just for delta t milliseconds. So here, if you have count plus plus, only within that call of function, the variable count is incremental at the end, but after the function call, the variable count will not retain its value. That means in the next function call, int count is equal to 0 is taken. Previous value of count is erased. Previous value of count is 1. We have clearly said that if you put a variable count inside the function, what happens? Separate memory is allocated. That is true. But the second function call, the memory allocation of count, that's same. But what happens? The initialization count is equal to 0 is again permitted. Previous value of count is not taken. So if you put count plus plus, or if you miss count plus plus, you will not have any effect in this example, because after count plus plus, we are not printed a value of count. So if you miss count plus plus, there will be no effect. But the logical concept is, please understand what is a scope and what is a lifetime with respect to the first storage class called auto. Clear?
Yes, sir. Thank you, sir.
Now have a look into the same example. I put a little modification. We need to introduce one keyword called static. Static, this is the keyword. The keyword static, this is used to define a variable with respect to a fixed storage class. So please think here what I am doing. Int count is equal to 0. I put one keyword here, that is static. Simply I put the keyboard static. Static int count is equal to 0. That's all. I save the file again. I run the code, control F9. Please look into the output. What happens? Call 1, count in G is 0. Call 2, count in G is 1. Call 3, count in G is 2. Call 4, count in G is 3. Call 5, count in G is 4. This output is compared with the previous output by removing the keyboard static. So clearly here, static int count is equal to 0. This is completely different from auto int count is equal to 0 or simply int count is equal to 0. Static int count is equal to 0 is completely different from the normal one, int count or auto int count is equal to 0. So in what way the storage class static is differing from the automatic storage class or by default storage class R2? Since the storage class defines how a variable is stored and accessed during the program execution. Here static, right, fixed that retains, right, retaining the value of a variable. That is the meaning of the keyboard static. Please follow the flow of execution. Initial value of I is 1. G of 1. A receives a value 1. Static int count is equal to 0. Since this is static int count is equal to 0, when I is equal to 1, A receives 1. I is 1. A formal parameter receives 1. Our static keyword is used to define what variable count, which is initialized to 0. Since this is a static variable is initialized only once. Only once. Wherever means where it will be. It will be in the function definition. That's all. It may be in the main function or it may be in the function definition, user defined function. Here, right, we have used the static keyboard in the function definition. So here, int count is equal to 0. That means since this is a static variable, count is equal to 0. This is initialized only once during its lifetime. This is very important. Still, we are having A is equal to 1. And what we have done, we have printed the value of A and count. Current A is 1. Count is 1. What is count? Count is 0. Yeah, not 1. Count is 0. 1 0 is printed. So we can see the outcome. Call 1, count in G is 0. Then count plus plus. What happens? Count plus plus. This updates the count variable by 1. So I modify here. Count plus plus. This updates count to 1. Function execution is over. Next, control comes back to the main function. In the main function, it seems that the next value of I is taken to say 2 less than or equal to 5. The actual parameter 2 is passed to a local parameter, formal parameter, local variable A receives 2. Then here, the sequential statements are executed. Since count is defined as a static variable, count is defined as a static variable. Initialization of a static variable is allowed only once during the execution of the program, during the execution of the function. So clearly, this count is equal to 0. This will not get executed in the second function call or even in the third function call, fourth function, fifth, sixth, seventh, etc. In any of the subsequent function calls, static variables will not be reinitialized. That is a rule. So the next statement, a printf slash and call percentage d count in G. Now what happens? Call, right? Call count A is equal to 2 is printed. Then the variable count is printed. Count, right? What happens? Since count has been updated to 1 because of its static storage loss, here we can see the outcome 2, 1. So A is 2, count becomes 1. So have a look into the second line. Call to A is 2, count in G is 1. How count in G is 1? Since count is made as a static variable, static variables retains static variable retains its value during the subsequent function calls. So in the first function call, count is 0. Then the second function call, previous update, this 1 has been taken. That is the purpose of static keyword. Just retains static keyword retains its value during function calls. So when I is equal to 2, it seems A is 2 and count is 1. Then count plus plus. What happens? Count plus plus. Count plus plus. Count is updated to the quantity 2. Then I becomes 3. A is 3. Current A is 3. Printed. Current count. That is previous value of count. That 2 is retained. So 3, 2 is printed. Then count plus plus. Next I is equal to 4. A is equal to 4. 4. Count plus plus. So 2 becomes next to 3. Here 4, 3. Then this 3 becomes 4. Count, right? I is equal to 5. A is equal to 5. 5 is printed. Last updated count. 4 is taken. 5, 4 is printed. So it seems 2, 1, 1, 0, 2, 1, 3, 2, 4, 3, 5, 4. That's what we have this outcome. 1, 0, 2, 1, 3, 2, 4, 3, and 5, 4. So the conclusion is the scope of static keyword is static keyword is again only within the defined function. Please understand the two words, scope, visibility. Second, lifetime or longevity. Lifetime of static variable. What is the lifetime of a static variable? Static int count is equal to 0. The first function call, count is updated to 1. When you call the function second time, count the previous area count is retained. So here, how do we define its lifetime? static variables or static variable retains its value during the function calls. This is the lifetime. So with respect to the function, single function, or you can call the function any number of times until you call the function last time, right? The value of the static variable is a fixed one. In case the count plus plus is not given, I tell you, if count plus plus is not given, now what happens? F2 control F9 in all the function calls, the value 0 is taken. Suppose count is initialized to 10, control F9 calls, the value 10 is taken. This updates the value of variable count. This initially 10 has been done only the first time. The subsequent calls, this initialization is not allowed. Subsequently, previous value of count, because of count is a static storage class, that value is accessible. That is the purpose of static keyword. Scope is defined only within the defined function. Since the count is defined as a static variable, this does not mean that count will be accessible inside the main. Sure, count will not be printed or accessible inside the main function because count is, even though a static one, but it's having a local scope only within this opening and closing variables. Wherever you want, we can access the variable count. That is its scope, accessibility, visibility. But lifetime is how long it retains its value is. Even in the function calls, until right you reach the last function call, the value of count remains same, or the previous update will be taken. That's what the lifetime is defined right within the function calls, so that static variables retain their value during the function calls. Have any doubts? We have explored automatic storage class and static storage class. By default, automatic storage class is taken. The variable declaration be R2 space variable list, data type variable list. Where in case of static, instead of R2, try to replace the verb static. Have any doubts? Okay, please go through the session. We will continue the remaining keywords right in the next session. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.